Hello, welcome to the 2015 200-120 CCNA course. We're going to get stuck straight into Chapter 1 now. Recognize the purpose and functions of various network devices such as routers, switches, bridges and hubs. So a hub, this is just the network symbol for a hub done in Visio, nice and simple. But hubs, bridges, switches and routers are used to build networks. And if you're trying to design your own local area network at home, then you probably need to know what they do and the main differences between them. I'll try to cover everything that you need to know for a basic kind of network design here, and a better understanding of how everything kind of works. Always remember that the internet, as you know it, is nothing more than a network of networks. It's a network of routers and switches. Hubs are used to build a LAN by connecting different computers in kind of a star hierarchy. The most common type on LANs is definitely a hub, not necessarily switches, especially at home. A hub is a very simple, or as we call it, a dumb device. Once it gets bits of data sent from the computer A to computer B, it doesn't check the destination. Instead, it forwards its packets, and not that it even knows its packets, but it forwards the message to all other computers. Let's call it a signal. It forwards its signal out every other port, whether it be to A, B or C. And any computer within that network that it's destined for will pick it up. Every other computer will just reject it. So there are two main types of hubs. You have a passive hub. The signal is forwarded as it is, so it's not really changed. We have an active hub where the signal is amplified, so they work as repeaters as well. In fact, they're quite often called multi-port repeaters, and they require a power supply, whilst other hubs sometimes don't require a power supply because they can just take it from the Ethernet voltage. And hubs can be connected to other hubs using an uplink port to extend the network. So a hub works on the physical layer, which is the lowest layer of the OSI model, which we'll come to. That's the reason that they can't deal with addressing or data filtering, because they just don't know about it. That's why they're called dumb. Now a switch. Notice a slight change here. Switches, on the other hand, are a lot more advanced than hubs. They don't broadcast frames everywhere. A switch will actually check for the destination MAC address in the packet and forward it to the relevant port. This way, a switch reduces traffic and it divides the collision domains into segments. It's a very, very good idea to have that on busy LANs instead of a hub, because it also protects the frames from being sniffed by other computers that are sharing the same network segment. They build a table of MAC addresses, and it'll list which MAC addresses belong to which segment. If a destination MAC address isn't on the table, it forwards it to every segment except the source. So if I was to send a message here on computer number 2 here, and it didn't know which computer it was destined for, say if it had an address on of .4 but it didn't know what .4 was on, or FF, then it would send it to number 3 and number 4, but it wouldn't send it back down to number 1 because that would be silly, the packet came from there. But also I suppose it's worth noting that if the destination is the same as the source, then it just drops the packet, it doesn't bother sending it back. Switches have built-in hardware chips solely designed to perform switching. Therefore, they're fast and they come with many ports. Sometimes they are referred to as intelligent bridges or multi-port bridges. Different speed levels are also supported on most switches these days. They can be 10 meg, 100 meg, or gigabit, or maybe even more sometimes if you have fiber links, etc. So the most common switching methods are cut through, which is directly forward what the switch gets; store and forward, which is receive the full frame before retransmitting it, or it also has fragment free as well, in fact, which means it doesn't alter the packet and it just sends it straight through. So switches operate in the data link layer, which is just above the physical layer, and that's why they deal with frames instead of bits and filter them based on MAC address. Switches are known to be used for their filtering capabilities, that's why most people use them. In VLANs and broadcast domains, switches don't control broadcast domains by default. However, if a VLAN is configured in a switch, it shall have its own broadcast domain. A VLAN is like a logical group of network devices located on different LAN segments. However, they are logically treated as if they were located on a single segment because they have a certain flag set to say they're on a particular VLAN. So here's an example of the MAC address table on a switch. You can get to it just by doing show MAC address table. You can have all the VLANs listed down the side here. So VLAN 1 is generally the default management one, and you can tell here that it's on fast Ethernet port 21. You have VLAN 4, which means it's on fast Ethernet port 16, and it's a dynamic port, and it gives you the MAC address as well. So when the packet's received in, it'll look at the destination MAC address. It'll scan this entire table, and if it identifies the one it's going to, then it'll look, see what VLAN it's on, which port it's on, and forward it out that port. So that's pretty much what switches look like there. I think there are a pair of 2960 stack switches. They have cables in the back, like stacking crossover cables, which basically means it'll treat two 48 port switches as one logical, two 24 port switches as one logical 48 port switch, but it does it. You can do it with failover as well. So instead of having one going off and then all of a sudden you're stuck with this one, you can have, if you do kind of teamed or bonded NICs on your server, and you have one going to port 1 here, stick one in port 1 here, and they can work in failover mode. So if one switch was to physically die because they have separate power supplies, the second one can take over and cope with it. So our routers. Excuse the bad picture there. Routers are used to connect different LANs or a LAN with a WAN, such as the internet. Routers control both collision domains and broadcast domains, and if the packet's destination is on a different network, a router is used to pass it the right way across to a different network. So without routers, the internet wouldn't really function. Routers use NAT, network address translation, in conjunction with IP masquerading to provide the internet to multiple nodes on a LAN under a single IP address. In modern day times, such as now, routers come with hub or switch technology to connect computers directly as well. You no longer have to plug a switch into it before you can plug a client into it. So routers work on the network layer so they can filter data based on their IP address. The routers have tables to store network addresses and forward packets to the right port. Which brings us nicely onto bridges. It looks like a funny little bridge there. Bridges are used to extend networks by maintaining signal and traffic. It's essentially a hub, which is the amplifier side of it as well. It's a multi-port repeater. Bridges are used to used within the data link layer. So in principle, they're capable to do what switches do, like filtering and separating the collision domains, but they're less advanced. They're known to be used to extend distance capabilities of networks, and in a comparison with switches, they are slower because they use a software to perform the switch rather than a dedicated chip, and they don't control broadcast domains, and they usually come with a less number of ports as well.